south. In the stress the stress basically direct indirect layer. Direct layer is normal stress have like aduga share have like indirect layer is in a bending ne aduga torsion ne. Bending has in suppose the bottom layer, let's say 6 fixed or say. If you are applying the force here, see the force applied to see it will bend like this. Bending is basically it is called bending moment. Torsion has a fee sumbado. Torsion has a fee sumdo, see fee sumbadoni. Other laibido. In a clockwise and anti clockwise, anime da laibido. That is called torsion. Normal the sergi like normal the magi stress magi stress to uniform stress will be developed like this uniform. Bending the it will be different, shared will be different, and torsion also will be different. Do you see the exactly same like this? Say A B have a role later. Sine anti-clockwise sine clockwise. So I fish lay within torsion nice. Okay, so the my equation equation everything will be depend on the equation. So the equation is same again derived the derived the equation say because we have convention in papers. So the derived you try from your end. Otherwise, sign a rectangular taper bar. If you need, I can send. But let's from your also just try derivation say. So my assumption is some money. Method of the SAF height is some money wrote is homogeneous and isotropic. Straights are within the proportional limit. All transverse sections remain plain and undistorted after twisting. Nasai see road layer. See plane layer. Inclined plane low sevego. Any inclined plane low is minor. Other distorted to height is my rotate torsion applied to the Magisigi bar see. Even though you're applying torsion, my planes straight way like the was minor. So when I distorted like we are there. So when I distorted like we are there. Then when all the transverse section remain plain and undistorted after twisting. In other words, the diameter of the sub remains straight after twisting. See the label diameter to max is like diameter should remain constant. This is the first assumption. Okay, especially for distortion. Diameter must remain unchanged. Sige assumption pala matungda derivation mayam tora matungda magi circular matang tora kanda sig equation je fangdoini. Mo question do. T by Z is equal to tau by R is equal to Z theta. Is a hyperte ulam gevako. Line aba. Magi n section do agency. Suppose I circle ni mong daloge. Still this is the center. O my radius R low say. सिगे बी दगिना ट्विस्ट तौदोइसी सिफो तौरसे सि थीटा से बी ड्याश फो बी दगिना बी ड्याश फो ट्विस्ट तौरसे जों साई मागी से एंगल थीटा से केनो सि खंगदबसे दिस इज कॉल्ड एंगल ऑफ ट्विस्ट सि एंगल ऑफ ट्विस्ट कवे सिदा गामा ना मियावरसी शेयर स्ट्रेन ऑलरेडी इक्वेशन तमखरे थीटा बाय एल r है सो रेडियस नहीं और यू कैन से रेडियन डिस्टेंस t से कई होइदेनो t से टॉक है देने पोट हम से रोटेट कर दी टॉक इज डेवलप टॉक है भी कहना फोर्स इनटू परपेंडिकुलर डिस्टेंस टॉक मींस परपेंडिकुलर डिस्टेंस सिदा मागी j है इसे कौन नहीं रख सिको j है इसे कहना पोलर सेक्शन मॉडुलस polar section modulus see derivation is a punkhai am changane ko adana we don't have time for that so just bear with that so the whatever the equation to the p is the khang the things higher take a decent top layer polar section modulus shear strain radiant distance okay so theta layer a layer my c l c ki sai kem to c length l and g is the constant value t by z is equal to tau by r is equal to g theta by l z is any constant value so it's called torsional constant so okay c khangagadi yengsi magi maximum shear stress se so the question nam lai ko yengsi aina first hike with the sai gi normal stress na apply to the magi stress ki magi nature of the stress is uniform al torsion de kayo ini torsion de si vere sen linear chikaw yade okay linear and because of that actually shear stress develop so that maximum shear is the minimum shear is tau is basically zero here the maximum shear is at the outermost surface so my maximum tau is 16t pi d cube chikaw yade 16d pi d cube this is the maximum shear stress developed during the torsion okay so mathang question lakching da sige polar section modulus something ngasai z se z hai di kaino hai matamda it is a measure of the strength maximum applicable torque of the shaft asomdana ke hai strength hai giba sidana polar section modulus chamane It depends on the shape and size of the cross section. Magi shape and size to depend on whenever that's it. See, for the polar section modulus, it is just like strength. Okay, it is a maximum applicable torque of the shaft. It depends on shape and size of the cross section. See, question is to abang bring se. Answer put it to open it. Yung apet. A shaft of diameter 80 mm is subjected to twisting moment of T is equal to 4 pi kilonewton meter as shown in the figure. Maximum shear stress in the cross section is MPa. मतलब you need to find this, okay, value do. T is equal to 4 pi kilo. So the mana kilo Newton meter piece is torque to nickel. Torque is equal to force into perpendicular distance. That means Newton meter. Things go. Mana putra is equal the maximum shear stress. My formula is seen through say 16T divided by pi d4. Adu my tau max ke alani. Tau max is equal to 16 into T की वैल्यू क्या है ना 4 pi किलो न्यूटन द पीरे ओके से मीटर ने एमपीए ने दैट मींस न्यूटन की 3 में ले रहे मीटर इनटू एमएम की 6 में ले रहे so 10 to the power 6 लानी all divided by pi ले रहे फॉर्मूला pi d क्या नो 80 mm 80 क्यूब देखो लो क्या दाम नहीं हो टाउ मैक्स सिंपल क्वेश्चन है 125 MPa so pi out say 83 क्या नहीं एक क्वेश्चन आता है चुपिरा की को व्हाट नॉट नाउ वो क्लास लोअर कांदा axial rigidity axial stiffness amti yang sini ti yang na hanpi ke bedo ngarang axial stiffness axial rigidity yang eko so sisa mind lai dun yang it is the measure of the resistance to the deformation under twisting. My value is ZZ. Another AE we give us, then GJ. Okay. Stiffness here gonna magnitude of torque required for the unit angle of this. Other than my force required for per unit area. So here per unit angle of twist. So GJ by L. AE by L in case of axial, in case of torsional GJ by L. Chap mani ko. So confuse ho gaya de. Ay question of tayo ko. Ay slide hang tiang wait. Is the poem layer. So let me take this point B, point C, point D. So the my twisting moment see 200 Newton meter peak. Let me say this is A, B, C, D. Like B the na anti my clockwise the 260 Newton meter. Here I'll give you 140 Newton meter. D the na clockwise the 80 Newton meter. Tam ta se go sorry nang area se confuse कर मैंने सीधा पुथोक्तो से what is the value of DAB? What should be the value of DBC? And what should be the value of DCD? खंग बे और दिहाई ओ खत्म खंग बे आउट है
Sir, diameter.
hmm
Diameter, sir. Diameter.
ना diametric just my torque value do shear force क्या पुतो है just torque value do ए मैं torque से just मैम height force dan ko puto के ना ngang when there is subject to so many forces, so we need to find forces at different section. So A section the might to kya hoy deno, B de kya hoy deno, C de kya hoy deno, D de kya hoy deno. Twist torment my value no can do ini.
AB 200 or sir.
A big 200. Okay. B C kiti
Minus 60.
minus 60. Correct. CD
Last is our COD with minus 80.
minus 80. Sure, this guy, 80 way plus 80 way. ꯁꯤ ꯁꯥꯏꯟ ꯈꯔ ꯌꯦꯡꯗꯣꯏꯅꯦꯕꯀꯣ ꯑꯩ ꯍꯥꯏꯒ ꯆꯞ ꯃꯥꯟꯅꯩ ꯑꯩꯈꯣꯏꯅ ꯉꯔꯥꯡ ꯑꯦꯛꯖꯥꯝꯗ ꯇꯧꯈꯤꯕꯗꯨꯒ ꯁꯤ ꯃꯨꯟꯅꯤꯡꯁꯤꯀꯣ ꯁꯄꯣꯁ ꯍꯣꯏ ꯀꯛꯊꯠꯂꯣꯔꯦ ꯁ꯭ꯋꯥꯏꯗ ꯁꯤ ꯂꯣꯏ ꯀꯛꯇꯣꯏꯅꯤ ꯃꯌꯥꯏꯗ ꯑꯗꯨꯒ ꯁꯤꯁꯤ ꯑꯦꯄ꯭ꯂꯥꯏ ꯇꯧꯗꯣꯏꯕ ꯁꯤ ꯑꯃꯈꯛ ꯑꯦꯄ꯭ꯂꯥꯏ ꯇꯧꯕ ꯌꯥꯏ ꯀꯩꯁꯨ ꯀꯥꯏꯗꯦ positive negative see left side na anti clockwise right side na clockwise negative log na left is clockwise aduga right is anti clockwise bab taramane hujte a b c may khaido left side to positive tare 200 positive laire b c c may khando b may khaidok pada se anti duna positive ni left side ki 200 minus 260 is equal to minus 60 nm. Can I go? Okay, so we'll practice more question as a homework assignment. Don't worry. So you get it. The psyche, for okay, this one. So theta amo yaurisi. So theta ke value si anta herone. This angle of twist. Exam thangi ko. How my angle of twist puthok se direct. Angle of twist. Suppose bar my circular bar rotam lower. My C side is fixed over say. Nang nakut na na buy of fee so link the with the fee to apply the ungu. My twist over the other direct to serum. Okay. Torque divided by polar section modulus is equal to z theta divided by L. So from here, your theta is equal to TL divided by ZJ. सिगे theta के value सी not in degrees degree दो ही रहेगा, it should be in radians. Okay, so this value should be in radians. So one say pi radian से मैं degree क्या हो जाए? No, pi radian is equal to how much degree? 180 degree. So 1 radian 180 divided by pi degree. सीखा बताए. My question this thing atani ko sidanan khang do isi mage what is the nature of the stress that will be linear. So the stress karam torsion si asing base share ni ko man develop to do isi. When a twisting stress hai wani torsion hai wani but the it is actually shear stress. Question kar like question say I'll just give you as homework, okay? Matang yang si BIM ko. Not in BIMs. I think with okay. Fine. Torsing was the bending. Bending stress classical BIMs. Let's see what is BIMs. So let's try to understand very carefully. BIMs the BIMs are the structural member used to support the transverse loads. Okay, column single that is called transverse loads. Okay, see transverse load height the plane the perpendicular. This all a transverse load. Okay, this all a transverse load. Okay, so any structural member that is parallel to the transverse load or the column, so that structure is called BIM. Okay, BIM is going to use something you know better, right? So color ki mathak ta chatpa line ko that structure that is called BIM. BIM can guess again. Anybody please? How many types of BIM? Can I type the BIM? Types of BIM. Select cantilever BIM, simply supported BIM, overhang BIM, drop cantilever BIM, continuous BIM, fixed boolean BIM. So among the nine खींचरो याद रहो. Yes.
Yeah, sir.
Okay. Everyone knows this one. Okay. So direct point the last. Okay. Space what वाला है. Fine. Loads से मखन क्या लाई? Anybody please tell me how many types of loads? Bending the neck or आगे axial the नत्ते. Loads basically there are three types of loads. Okay. One is point load. One is uniformly distributed load UDL. One is uniformly varying load UBL. Okay, so everyone knows it. Point load, uniformly distributed load, and uniformly varying load. Okay, that's it. The point load kiti came later. Direct my point load to load doing. Uniformly distributed load. There is a beam. Over the beam, there is okay. Magi. So this is called uniformly distributed load code. Magi is the length pirani. Ado magi sigi awang bodu. W pirani. Load kya ho jano? What should be the value of load? Okay. Likewise, W
WL
kya?
square by WL square dot 4.
WL square by 4. Mine I know L square is 4. Suppose CNC is the UBL layer, uniformly varying load layer. See basics very important, okay? CNC. So matam khan logo ni ko. 1 mark this way direct convention and is the 1 mark na 1 question. See the L layer. Mag is sigi so nang WP re. See load. Kya ho jano? Actually, this W is not the load. This is the actually it is called load per unit length. See, in case of UDL or UBL, the area will give you the load. The area will give you the load. See the my rectangle shape ni rectangle again my area to length into breadth nutro length into breadth. Aduga see W and the magi load si kya hoine P is equal to W into L. Sidana kya hoine UBL dana your load is equal to half into W into L, half into base into altitude, right? But the question is that this load will be acted where? At the centroid. For the rectangle, suppose it is L, so L by 2. The centroid is the middle point. So centroid for the rectangle should be exactly at the middle. Atuga triangle ki dikai doy. Doy ni centroid se. Okay. So this distance kya ho jaiba? Sine kya ho jaiba? Load se Sigina centroid sida ek taurani. This load is called WL. Aduga Sigina centroid sida load ek taurani. My value se kya?
2 by 3 or 1 by 3.
Huh?
2 by 3 or 1 by 3 sir.
2 by 3. So my L ni piece na yung tumdori ko 2L by 3 yes. Charuk ahum thopig ani. Sina? Wait. Sina saruk ahum thopig ani. Sina saruk ahum thopig amma. Okay. So So first I'm repeating once again. These basics are very important. For UDL, your load is equal to W into L. Magi load P bitugi adoga centroid ta taba. Okay. It will be X and the centroid. Load magi sigi W umpirani sigi length into L will give you the load. For here also the area will give you the load. So area is half into W into L. See types of load later. Okay, topic for the how to. Okay, so 12 by 3 later L by 3 WL by 2. This is the load. Okay, for UBL and for UTL WL. നമുക്ക് share first class share for size के no internet for the section is see the load external load p so external load ngada this is our external load because of the external load यहाँ पे internet force are developed transverse perpendicular to the beam so that internal force is called my shear force है जब माने bending stress का shear stress का suppose the beam में ले रहे whatever the shear force left side will be equal to surface of the right side. Whatever the bending moment, okay, on the left side will be equal to the bending moment on the right side. What is the equilibrium, the balance condition? Okay, so whether it is shear force or the bending moment, see on the left side of every section will be equal to on the right side of that section. Sign convention so make so okay, my headed peggy side to upward again a positive law, downward again negative law. Okay, right side kilo again downward to negative law, upward to positive law, negative law. The confusing way when it just am a color some yai. Chitty problem what the Nasanam Kankanigo. Okay, SFD BMD draw the rock training and see the Enkamada Nangdo Mande and see the best section in a scene. Doing haying Fazana, SFD BMD, we have to draw it. Okay, bending moment is the internal moment at the section. Yes, correct. It is equal to the sum of the moment of on the forces, either left or right side of the section. Okay, as I told you, if you cut at any section, so the bending moment on the left side will be equal to the bending moment on the right side. The shear force on the left side will be equal to the shear force on the right side. Bending moments aim na denote the way. So bending moment is sign convention. So it's sagging, hogging, ऐसे. Okay, so Maina, si Smiley, no ini. No ko sila saging gawe, sila set oiba gawe. Set oiba sila hogging gawe. Okay, left side ki clockwise na positive. Okay, sig side se na anti-clockwise positive. Likewise, here anti-clockwise is negative, clockwise is negative. Sign convention is also very important here. So, question torokan to gyanta kani ko yengsi. Now, this is a very important area. Like the relation between shear force, this load, and bending moment. There is some relation. Is space right there. Okay, it's the ego. A relation between load intensity high with W do. Shear force and bending moment. Karam tai se. See,
Sir,
shear force. Yes, hello. DS by
derivative of shear forces are load command and the moment kina shear force ka.
derivative of shear force is equal to.
Load
Okay. My derivative with respect to you know.
x.
Yes, x means the side is c. See, it is varying with the x. X equal to 0. This is x equal to L. Yes. Okay. So derivative of shear force with respect to x, it is nothing but load intensity. However, it is very important. Second thing, derivative of moment with respect to x is equal to shear force. Derivative of shear force with respect to x is called load intensity. Derivative of moment with respect to x is called shear force. In other words, we can say like this. In other words, what color I have to use? Okay. So look at here. Integration of ds. Okay. So is equal to your integration of w dx. So integration of ds means your okay shear force. So it is integration of load into with respect to x. Likewise, likewise, your moment is equal to integration of shear force with respect to dx. These are the relation between load intensity, shear force, and bending moment. अब याद देखो अदु बतागते हाई से just tell me one thing. सीधा मैं load zero है रे load zero का है load zero this w0 shear force के वही नहीं रहो according to the relation between shear force and load. So when your load is zero, what should be the value of shear force? Anyone please tell me.
Constant.
Constant. Very good. Okay. Shear force. When load is zero, the shear force will be constant. Yes. So here your shear force is constant. When load is zero, your shear force is constant. Okay. So when shear force is constant, what should be the value of bending moment? I the value nate. Mage graph to linear or either kayo ina. What should be the degree? Degree taisi.
Linear.
Linear. Karamba graph to karamba equation dekhange. Sidagi
Hoja.
or from here. From
Integration
here.
here.
Okay. So see constant value. So what is the integration of 2 dx? This 2x, right? So now degree will be 1. So when shear force is constant, your bending moment is bearing with the x. Okay, Kavya to say. Your bending moment is bearing with the x. Here degree 1. So linear. Kavya to go when load is 0, shear force is constant and bending moment is directly proportional to x. That means degree is 1. In the same case, here the load is constant. When the load is constant, load constant shear force will be bearing with the x. Okay, so degree here 1 degree. When shear force is bearing with the x, may integration down say integration to with x square allow it draw. See constant later. Constant again integration to suppose c dx integration to or cx lie. Okay, that means that value. Okay, your shear force value is bearing with the x. Shear force is bearing with the x. So again, this cx, again integration of your say x dx, so it becomes x square. So m is becoming x square. So when w is constant, shear force is linear 1 degree and bending moment is 2 degree. Okay, bending moment is 2 degree. When the load is UVL, when the load is UVL, okay, so already with respect to x, integrate करने से see, so integrate करो kan square लानी, so this is shear force is directly proportional to or is the function of x square, so it is 2 degree. Again, if you integrate this one, this is 3 degree. So home when the load is 0, shear force is constant, bending moment is 1 degree. When W is constant, shear force is 1 degree, bending moment is 2 degree. When it is UBL, okay, or it is bearing with the X, your shear force is 2 degree and bending moment is 3 degree. See degree is a question to hangi ko. Reaction puto putam si unknown. Saya matan ni kita matam lo se. Này có ai slide xem mình slide lại thôi này. Screen याद हो तो है वो कोई stat yang dia ba. Koi depth tu reko khang adum question adum nahi na so nahi na betul. Ai beam mom loge. I am taking a beam. What happened to the color? Yes. So either cantilever हम लोगे. Okay. I is the load P have a एक तो होंगे. My length of the beam से L नहीं. So my suppose C A होएगे, से B होएगे. My question is find support reactions R or bending moment. Try to say here.
Sir, R की value ga load की value का माना गनी अदु दुगा moment की ना load into length.
RCP whenever.
R C P gitu. Aduh juga
The
moment की
R
ना
P
masa
into L.
habio. M na P into L.
Sida si kya mabim mo doino.
Cantilever beam.
So cantilever beam C magi unknown support kya ho doino, reaction kya ho doino. Khangba. I just want to skip. That is why I'm just putting this question. Okay. Sikhang the convention. I'm talking about convention. See, SF the BM the question. I'm destroyed. 20 marks. The question the lurakan ilaro convention and the.
Free end sir 0 ꯑꯣꯏꯗꯧꯕ ꯑꯗꯨꯒ fixed end minus moment WP square by 2 fixed end.
Okay. Nay reaction kya no marwani ro.
So reaction ama.
Reaction amma. Amma khatro yaw jani ro. Am khatro.
Sir, ama kata boleh gitu. Load si P kata
Amma.
boleh.
Okay. So see how the support ngata line the yadre ko. Support kita ngai. First ladies see roller support है हमने pin support है हमने fix support है हमने അങ്ങനെ देखो suppose से beam हम ले रहे कि roller support दिसी हो जाए see कोई 2D ngata ni ko si 3D ले रहे सीधा ले जैसे x है हमने y haibamne. Okay, the reaction the vr haibamne, x r haibamne, horizontal reaction haibamne, vertical reaction haibamne. Okay, sige roller support si magi x y the cochain channel lairane da reaction hai is when it is constant fazil kandane ma reaction thok to iche. Okay, fazil kandane ma reaction thok to iche. The my say left right channel lairane, so no reaction on either. So in the roller support your eyes are horizontal, there is no any reaction. But what about in vr, in y direction? Yes, ma y mathak to change ngamudane ngamoy. Okay, because of the constraint. Okay, so khangadabasi in roller support there is only one reaction. Okay, so that reaction is vertical or in y direction kawade. Okay, when there is roller support there is only one reaction that is towards y, that is called vr, vertical. Mathang yengse in the this is a beam. Chidi answer 0 hoigadro br 0 anyway right.
reaction ani hoigani sir.
Okay, yes. So here answer is not equal to 0 and your VR is not equal to 0. Okay, so the VR so like any heights are so like any. So in pin support there are two reactions, one is along the y, one is along the x. Okay, now what about the fix? What about
Fix
the
the
fix?
ahum sir.
Ahum side amai kime. This is
Ai
fix.
ahudre sir.
Okay, so this is fix. Fix the this is ITR, this is VR. Amna kari
Sir moment n
moment
moment से कमाइना suppose आइना load से समाइना एक तोड़ दे my direction ढाई से load से समाइना एक तोड़ दे direction तो clockwise हो जाए anti हो जाए
clockwise hoigado sir.
तो माँ से clockwise उंगा नहीं है से balance तो दुई नहीं माँ के सिगी load से ना clockwise तो उंगा नहीं और तो किसी तकी reaction ना माँ थिंगा कदोई नहीं बा in opposite
Duna
direction
sir anti clockwise hoigani sir.
yes correct this anti clockwise kaya नहीं अतो क्या साइगी
Sir do kainomda hangjauge sir. Kaigumba the moment vertically distribute toragadi magi horizontal reaction do id 0 hoido natro.
wise चुम्मे अतो ना reaction तो मागी zero ए तो मागी equilibrium condition तो वही बने बा सेंग बेदी मैं लई दुई ने बा reaction zero है बेया देवा अतो यह रखे बा को reaction दे लई दुई ने बा नहीं होई value दो बुते zero in equilibrium condition से zero होई दुई ने बा that is correct. Okay, अतो है रखे से सीधा बीमम लई रहे. Okay, आई load से मखा दे पी रिस माइना अतो इधर माइंस माइन लई रखे दुई ने बा anti-clockwise. See anti-clockwise already moment see clockwise direction. So in fixed support there are three unknown reactions. In fixed support there are three unknown reactions. So the question is yes sida heights are haibam lairani BR. So it is clockwise. So in anti-clockwise one is moment at A. Yes. See, rest the layer. So we need to apply our equilibrium condition. Okay, we need to apply our equilibrium condition. So equilibrium condition, the summation of fx is equal to 0, summation of fy is equal to 0, right? So summation of fx is equal to 0. The sum of the force along the x-axis is 0. X-axis is the are. So obviously in equilibrium condition, your IHR is 0. So it doesn't mean that there is no any reaction along the horizontal line. Yes, there is. But in equilibrium condition, there is no any other reaction to balance that one. So that is why the horizontal reaction is 0. Okay. Aduga, we are summation of Fy is equal to 0. Upward positive love say, downward negative love say. Okay. So this is acting upward. So Br minus say P na throw. This is P is acting downward. So minus P is equal to 0. So your Br is equal to P. Okay. Br is equal to P. So we have found two unknown reactions. Moment क्या होता है? Moment is F into perpendicular distance. So moment at A is equal to P into L. P into L. Amga to sigo. I think kita tulo jeng theng reba ko. So we will match this timing in the next class. See bimam later. I is the fixed okay. Okay, and the roller ram ka hapke. Let me say this is A, this is B. So exactly at the mid span, length C L L C exactly at the mid span, there is one point lot P. The find the unknown reactions and moment. क्या हो जाए
B the 2 sir.
B the 2. Okay.
Sure, PL by P by 2 the reaction. A ga B ga.
Reaction C sida BA hai bam lai rani. Sida BB hai bam lai rani. See fixed termina C side ta. C side ta. Right side hai bam lai rani. Moment like it.
Later sir.
Okay. So in the high give the summation of fx is equal to 0. So minus IXR is equal to 0. So your IXR is equal to 0. summation of Fi is equal to 0. Okay, so BA minus B plus BB is equal to 0. So BA plus BB is equal to P. So BA BB कौन find तो देगा? Okay, say homework pige. Hang sa na inase. Say moment lang din ko. Moment later so because of this P moment like we never. So unknown nate. One known moment will be there. Okay. See moment. Say I'll be asking in the next class tomorrow. Okay. Let's end over here. See you tomorrow. Okay. Bye.